Hello, everybody. Welcome to Old Man and the C Sharp. Bow, 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 bow. I'm going to explain what this is real quick. This is a weekend code camp to go from zero knowledge of programming to making a game in Unity. Because we only have a weekend, I'm going to have to go very fast, but I also need to go very in depth and very deep. And I got to do it from a very beginner perspective, which is why I have this. Let's turn on Pro mode. HDR Pro Gamer. Uh, I've got a pink box around my face because I'm using just a Windows Surface laptop. Just off the shelf everything. I don't even have a second monitor to run, so you can see a bit behind the curtain with this down here. Brr, brr, brr. I can hide that though. Um, yeah, I'm gonna cover some basics. I'm gonna go real in depth as to what it means to code and what it all is. I'm gonna assume zero knowledge in programming. I'm gonna assume you have a little bit of familiarity with Unity. Maybe you're an artist or a writer or a producer or something with a team and you just want to learn a bit more. But I'm going to do a bunch of basic fundamentals on that as well, just really quickly to get you up to speed. I have the thing that has numbers that go up. Stopwatch. I'm gonna have a stopwatch in the corner there because I'm going to be using that to allow you to fast forward through some of the boring bits. But I'm really used to teaching in person, taking questions, reading the room, and diverging where necessary. Obviously, this is a one-way communication medium, and I can't do that. So I'm going to be breaking this up into this is Saturday morning, very first intro class. We're going to do 3 or 4 episodes per day, and we're going to hopefully get you there so that you can get brand new skill under your belt this weekend. Whatever weekend, this weekend, the Rona, September 19th, or whatever you're listening to this on. Another thing I'm going to be doing because I'm used to teaching in person, I'm not going to be editing. I'm not going to be making this super slick and fancy and fast paced for YouTube culture consumption. This is just going to be a class like I would normally teach it. So, yeah, it's going to be done in a single take. There's going to be no redos, and there's going to be there's no script. There's no, it's just off the top of my head the way it was meant to be done. So, you should go start downloading Unity at unity.com and get pretty mountain background on your laptop. Yeah, unity.com. They got a big get started button, and you just click follow that through and just get whatever's latest. They have an individual tab. It's free. You can download, and this download will contain every single thing you need um, to follow along. So that's it. I'm going to start the clock now, though, because I'm going to give myself 2 minutes, no, a minute. I'm going to give myself 90 seconds minus this preamble. Fast forward if you don't want to hear an introduction about me. 90 seconds, minute 20, minute 30. Wow. Wow, I'm bad at. I need my coffee. I'm not just stalling because I don't like giving introductions. I'm Andy Moore. Hello. I'm currently Techromancer at Absurd Joy. Um, I've been writing code ever since I was very little, and I really enjoy the process of writing code. But the most important thing about me is that I'm a pilot. I like airplanes, I like flying, but I like it so much that it is just my passion hobby. And my professional career job is only my second place favorite thing in the world, which is creating code. So I'm a big fan of code writing, code creating. I am old, so I've been working in this. I've been working in Unity and C Sharp specifically for 10 to 12 years ish. I spent a lot of time in Flash back in the day, and hacks and JavaScript and Turbo Pascal, blah 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 blah. C, bunch of different languages and things. And yeah, here I am. I've made several companies, made a bunch of games, but one of my third passion, airplanes, code, and teaching. So there we go. That was a nice 90-minute fast forward. Everyone can come back in the room now. You're not here to listen to me or see my beautiful magenta outlined face. Of course, the box goes away right then. Come on back. There we go. Okay, let's just jump right in. I'm going to do a 3-minute introduction to Unity. So hopefully you've downloaded Unity, you've installed it, and just install with all the general recommended presets. um, yeah, and when you first open up Unity, it's going to ask you, actually, you double click the icon on your desktop and you'll get a screen and it'll say create a new project. And the default is 3D and it'll stick it somewhere. That's fine. You can give it a name if you want, but it's not necessary. Just click create. And once you do that, you'll be at the same point as I am right now, and we can launch into this together and do a tutorial. So I start the clock. If you don't want to see a basic Unity intro, come back in 3 minutes or when the clock says 0 again. All right, now that they're gone, let's open up Unity. I already have it open. Wow, look at me wasting time. Boom. This is what Unity looks like. Default fresh install. When you start a new project, it'll just take you to something that looks identical to this. I'm currently using Unity 2020.1.6 F1. That's just the latest public non-beta version of Unity that's currently available. So whatever is free and available there. Unity, I'm going to get a lot more into detail on how everything works a little bit later, and there's a lot of tutorials that do a really good job of explaining how all of this works, so I'm just going to go over super basics. But there's the idea of a game view and a scene view, which defaults to these tabs right here. And you can reorganize however you want. You can move them around and do all sorts of fancy things. The game view, this is what the player will end up seeing. This is the actual output of your project, which as you can see right now is just a default skybox and nothing else. The scene view is kind of an authoring tool that lets you kind of scroll around. You could see the game view camera there. You can see there's a light in the scene there. And those are represented here in the hierarchy view. So this is my scene. You can see there's the camera and there's the light. And that's kind of basically the fundamentals of how Unity kind of works. If you want to create things, you can click around at the scene view, or my favorite, you just right click here in the hierarchy. You want a 3D object like a cube. Boom, we now have a 3D cube object here in the scene. And you can move it around with all these different handles. Fun times. And if I switch over to the game view, we can now see there's a cube in the game world. Now in Unity, you can hit play and that will start the game. Yay, the game is now started. And you can hit play again to stop. And you can see it kind of fades out the screen to let you know that you're in play mode right now. Now nothing's happening. Well, that's, we could do some things here in the editor. There's going to be a ton of tutorials on this. I'm going to add a rigid body to this just to give it physics. And I'm going to create another cube. And I'm going to just cheat real quick. I make that cube super tall, and I'm going to squish it down, and I'm going to lower it. And then I'm going to go back to the game view. I'm going to hit play. And because I added a rigid body to the cube, it now obeys gravity and it just falls. That's it. That's our game. Cube fall down. Launch that on the asset store. All right. So we're at about 3 minutes. Again, there's a ton of tutorials on Unity. I assume you have some basic knowledge on how Unity works. But the thing we're most concerned with here, boop, boop. So the thing that we're going to be focusing on is code. So how can we make something happen when this cube fall down or user has input or something like that? And for that, we're going to need to use a special window called the console. Now, the eagle-eyed out there will see that the console is one of the tabs down here in the project view. Um, this window is one of the most important windows for programmers. So what I'm going to do is I'm actually going to bust this out just by click and dragging. And I'm going to move it over here next to the inspector. So the inspector is when you click on something, it kind of shows you what's going on. The console is going to be outputting all of our code hints. So console is our best friend. If you lose the console, window, what is it? Analysis? Nope. Sequence? Nope. I always have it there. It is under general. So that'll pop back open for you if you lose it. So the console will also output here in this very small gray bar at the bottom of the screen. That's also kind of the last line of the console. So you always have that to look at. But this is where we're going to be doing a lot of our work. All right. So before we get into code in general, we're going to have to do a little history lesson on code and what it is and how it works and how to think about it. So let me just squish my face down a little bit. And, oh, sure, let's slide that over there. And let's open this up and start a new document. Oh, I'm not going to need that. Because I'm going to be doing, this is me emulating as if I had a whiteboard in the classroom. So a lot of people see code and they see things. Oh, geez, what if I just Google code? What do we get? Yeah, like these things, like this. What a header. Uh, like people see all of these symbols and everything, and it could be very overwhelming, and it can be very scary and frightening. Um, and one of the you see a lot of people arguing about what language is best or what tool is best for what job. And honestly, a lot of this comes from just a natural human instinct to resist whatever's new. But I assure you that all of those brackets and braces and symbols and signs and everything, once you learn them, which will just take time, it will become second nature to you and you won't see them anymore. And then the difference in syntax between one language and the next is going to be very, very like trivial. It'll be trivial. The thing that matters is the actual content. What's actually contained in the language or what tools you have available to you to create output. I tried to make an analogy about you could be really good at calligraphy, but you can only know how to write the word pizza, and it's not so useful a skill. The analogy doesn't really work all that well. It breaks down. But um, so syntax, which is the way code is decorated, the way it's laid out, is unimportant. It's necessary, but it's not important. And I'm going to try to get to the core of what is important about programming. So the number one thing is to understand how computers work. And I'd love just to open up a new code window and say, make the game, then run it, and there, done. Where's the go button? Ship it. Like that would be great. But that's not reality. That's not how it actually works. You have to actually break it down. One of the most common ways of explaining this is the make a sandwich routine. There's some YouTube videos of like parents doing this to their children, but it's a really good exercise, and it's just basically uh, make a sandwich. Now, to a computer, sure, no problem. Some languages might have a make a sandwich function, but what a computer will actually say is, well, what does make mean? And what does mean? And what does sandwich mean? And you have to start defining out all the bits. The easiest way is maybe to just try to write it down into a series of logical steps. And there's my end key. I'm working on a laptop, so I don't have my full keyboard layout. So in a language like here's my favorite language. There we go. So that's how you tell a computer how to make a language, make a sandwich. But in if this is binary, this is how all computers work. And we invented a language called uh, assembly. And assembly is kind of the lowest level human readable computer language. And I don't know assembly, but it looks something like this. Um, um, make get com, compile. There, there we go. Um, so assembly at its core is just a series of instructions, which are always like 3 letters long, and then like a memory address. And it's possible for a human to be like, okay, so you're moving this memory address and then you're copying this one, and you can kind of reason how a computer is going to be doing something very, very low level. Uh, but that's not good for us and what we're trying to do. We're just trying to make a game, we want to make a game. So we have higher level languages than these two low level languages. It's just kind of the bare metal and low level language. And then a higher level language, um, you're going to get languages like C, which is a very common old kind of, I guess it kind of bridges the gap between low level and high level languages. And something like C is going to have probably, if you've ever seen hacking in a movie, if it wasn't HTML, it was probably C or something like that. It's just kind of the common code standard. And from C, they've made a bunch of different ones. And we can start getting into a lot more nuance with things like C and beyond, including C sharp, which is different from C. Why? Doesn't matter. Out of scope for this conversation. So in C and beyond, you could be much more plain English, heavy air quotes on all of these words, where you can say, like, uh, 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 bool did player hit enter, if did player, no, wait, if player hit enter equals input from keyboard. There we go. And then you can say if player hit enter, win the game. Else, lose the game. Now, this might be confusing or hard to understand, and especially without syntax highlighting or nice colors, but at least what I'm trying to show here is that this is much easier to understand than this or this. But the key thing here is that the job of a modern compiler or a game engine like Unity or Visual Studio, which we'll be using, or C Sharp, which is a high level scripting language, it compiles this into this. And then this gets converted to binary on the computer, kind of automatically behind the scenes. So being able to write in this kind of high level, easy to read language allows us to have fine control without needing to know things about memory addresses or memorizing obscure 3-letter titles to everything. And assembly, in turn, prevents us from having to reason out what 111101 means in this context. So these are all just tools on tools on tools on tools all the way down, and there's higher level languages than C or C sharp, and there's lower level languages. The whole universe, all sorts, tons of things you could do. Okay, so let's go back to making a sandwich. Here's an exercise you could do at home. Uh, you should pause this video or just do it while I'm droning on and taking a sip of my coffee. You should get out a piece of paper, like I have, with this perfect, beautiful, crisp piece of dead wood I have right here, and write out all the steps it takes to make a sandwich. And you might be like, one, to take 2 slices of bread. 2, put butter. No, butter's gross. Who likes butter? Put cake on bread. Add extra frosting, and then eat. Something like that. And uh, often when you present children with this challenge, they'll come up with a list as this, but as short and as simple as this. But you have to understand, to a computer, it only understands numbers and basic concepts. So it's not going to really know what a slice of bread is and what does take mean and where do I find the cake. So you have to end up kind of busting this down into subtasks, right? You're like, okay, so take 2 slices of bread. What is that? If this is like a macro in like World of Warcraft or something, or you're playing some old MMO, or what does take 2 slices of bread mean? What is it? And you say, well, first you open bread box, and then you with hand grab loaf, and then take 2 slices from loaf, and then see, I'm starting to think like a programmer already. Put 2 slices into hand and like close bread box. So I think this is redundant now. Look at that, delete encode, nice. Into other hand, there we go. And we can continue this exercise out with step 2, 3, and 4. But you may notice we don't know like what open bread box means, right? So why don't we bust that out into subtasks? So open bread box is like grab bread box handle and like, wait, this is a definition. So we're going to grab the bread box handle and we're going to pull towards our body, and then see, this is getting hard. Yeah, so maybe that's good enough for open bread box. But then the computer's going to be like, well, I mean, what's grab? And you're going to have to, well, grab is this. And, well, what's a handle? And you have to be like, well, a handle is this. And you could see how it's kind of like a child that asks, why, why, over and over and over and over again. And this is for this reason, like you can see this is getting very complicated, and we have to define a lot of things. Like, now, like, what is our body? What does pole mean? What is a handle? What is a bread box? If you're going to make a video game that is just making a sandwich with this fine level of detail, it would be hard. It would be a very hard game. Like, there's a very good reason why actual game development is something more akin to jump when spacebar pressed. Because if you say like press spacebar, if you break this down into its component tasks, it gets much, much simpler because now if the computer's like, well, what's spacebar? You could just say, well, hey, Unity will tell you, ask Unity. And then what does jump mean? And it's like, well, jump is like run an animation, right? Right? That's all it is. And if it says, well, what's an animation? Then you say, ask the artist. Done, right? Like this is so much easier than making a sandwich because you don't have to define like physical human mechanics and physics and complex behaviors of, blah blah blah, right? So the act of programming is simply breaking your expected result down into the smallest possible components as you possibly can. Just kind of crunching it down into things that will be easy for the computer to understand, and in the process, you will probably change your concept because you start realizing what's hard to explain, and then you will say, well, if that's so hard to explain, maybe I should switch it to something else. So you could say jump when, or sorry, so if we convert this to make sandwich when spacebar pressed, great. Well, we have this reusable code already written here, so we don't need to solve that part anymore. We already know it works. It was making your guy jump the other day. It was no problem. But now we have to make a new make sandwich routine, and you might just be like, okay, making a sandwich is just running an animation that an artist made. No more physics interaction, no more crazy like defining hand and arm and bread box and what a slice is. You just play a video clip or something. Easy peasy. Now making a sandwich super easy. But this version of make a sandwich, it doesn't have physics, it doesn't have complexity. The user can't like add mustard. In this one you can, but this one is way harder to write and will probably take you like weeks of effort, right? So that's kind of what programming is. It's kind of just breaking things down into base tasks. I'm going to spend some time now showing you some really basic pseudocode. So pseudocode is a fun thing that we do to kind of showcase what you might want to do using syntax and layout that is similar, because I want to introduce you into some concepts. And I'm going to show you why. I'm just going to pop into actual code for a quick second, but I'm going to pop right back out again. Okay, so in Unity, in the project view, you can just right click and you can say create a new C# script. You're going to use this button a lot, so you're going to remember where this is. You'll get it down to muscle memory. When you click that, it'll ask you to, in a very non-obvious way, it's going to ask you to name this. So I'm just going to call it, I don't know, hello ants. Hit enter. And if I double click on this, it will open up Visual Studio, which is included with Unity, so you don't have to worry about installing this. Oh gosh. Security alert. So it creates code for you. It kind of, when you open it up for the first, how do I close this window? Go away, you Windows. So this is kind of the default Unity script. And even looking at this, even though it is structurally empty, this is almost pure syntax, basically, right? This can be overwhelming and scary to some. So to explain why we have this and why we have this and why we have this and what are these things, um, to better explain that, I'm going to show you some pseudocode. I'm just going to type out some things and show you why we got here. Like why is this a good thing? And why is that going to save you time in the end? And why it's not so scary once you understand what's going on. To that, first thing I'm going to do is I'm going to write a very, very simple procedural program in a language called Fake Basic. Basic is my first programming language, and it ran on old computers before the internet. I think it still works in Windows 10. It's very simple, and it's very easy to understand. Um, it has something called line numbers, and you basically just say one, uh, like print hello, like two, print goodbye. Um, and then you run that, and it will just output to your screen hello, goodbye. I'm going to fake a console here because it's faster than opening an actual console, I guess. Um, so one of the problems with languages that have like required line numbers and things is, well, now I need to I want to put a line break in here, but I didn't tell it to put a line break in. So I want to add a line break in between. How would I do that? Well, I would make a new line in here, and now two's taken, and now I have to go through all my code and like change all of the following numbers. So this is why in many basic things you'll see people write with numbers of 10. They don't have to be in sequence, all right? They have to be in sequence, they just don't have to be like the literal next number. And the reason for writing it like this the first time is that you can now go 15 and just insert code into the middle and it's okay, right? And the programmery term for a line break is /n. Um, I'm not going to cover why that is on this tutorial, but this would change the output to something like this. Now, there's the bane of programming. The thing that will always screw you up is user input. User input is always like humans into the mix is just going to ruin your day all the time. Programming is super easy as long as humans never touch whatever you're working on. And a lot of computer science education on or around programming language and things, they're going to assume that there's going to be no user input. You just want to write a program that does nothing but has inputs and outputs, and everything is great, and you can theoretically design amazing languages and code that work with no human input. But we're talking about video games. With video, it's all about user input, right? So we're going to have to discard the platonic ideal of code and instead write code that's resilient to humans, or at least responsive to humans, right? That would be nice. Look at this program here. Can't do anything. All it ever does is ring hello, goodbye. Like, what if I want it to say hello, but if you press enter, then it says goodbye, right? Then you do something like input from keyboard 7. uh, so if input is enter key, go to 10. So I'm going to expand this out a little bit. 8, go to 20. Okay, so this is still pretty human readable. In Fake Basic, input from keyboard, all it does is it makes the word input contain whatever key it is that you hit. So then you can see in pretty simple terms, you know what, I'm just going to remove the line numbers. You get the point. Oh no, I need the line numbers for some of these. That's okay. We don't need line numbers in every line. Okay, so you take the input from the keyboard. If the input is the enter key, then go to 10. It's telling it, don't even look at this line. Don't even look at this line here. Just go straight to line 10, which is this. Now, if it doesn't do this step, it is going to process this step. So it's going to go to 20. It's going to print goodbye. So now if you run this, in Fake Basic, the output will just sit there like this at a command prompt, and it's going to flash its cursor at you until you press a button. And if I hit spacebar, then it's going to not run this. It is going to run this, and then it's just going to go here and print goodbye, right? But if it's sitting there on the command prompt and I hit the enter key, then it is going to do this, and then it's going to go to 10, and then what's it going to do? It's going to print hello goodbye. Because you told it to go to 10, it goes to 10, it prints hello, and then it continues on its merry way and prints goodbye. Look, we just made our first bug. Yay. I'm just going to put that in there. So how do we solve this bug? You don't want to say hello goodbye. You want to just say hello. Well, what you do is you'd make another line number, something like that, right? Oh heck. Oh heck, what am I doing? Going back in my Word. 40, 50, 60. This is going to be way easier to understand, I think. The layout just looks nicer too. Yeah, okay. So end is just a command that just ends the program. If you just let it run to the end, it'll also end, but it's a specific end. The reason we did that is because now, there we go. See? So now, if you just follow through logically, gets the input. If you hit the enter key, it goes to 40. 40 prints hello, which is what we want. So it says hello, and then it goes to the next line, which is go to 60, and 60 ends the program, thus skipping the word goodbye. Easy, easy, good, right? Easy, good, fun. Go-tos, this go-to command actually does work in many modern languages. It still exists, but people realize real quick that having to do all this maintenance on line numbers, right? And doing this 40, and then I inserted this 45, and then 50, and then I ran out of space. And heck, even in this example, I had to go through and edit in some different line numbers. That's a bad idea. What's a better idea is let's make some labels, right? Let's make some labels, and then you could just go to the label instead. So I'm going to make a label down here that is so usually the syntax for label is just you write like print hello, and then you put a colon. That's now a label. Everything that follows this is part of this label. In here, we're just going to print hello. And then we're going to, up here, instead of go to 40, you just say go to print hello. Easy to understand, right? And now, if you hit enter, it'll go here, it'll print this, and then it'll just end because, or we can just write end. Done. And we could put a print goodbye, which also ends. And then this one, go to print goodbye. And now we don't need any of this code. So this code looks like it's not one big chunk. It's not one big chunk that just kind of mixes in the good and the bad logic all in one place. We've kind of split it out into two different labels, which is much easier to understand. And if you come back later to this and you're like, oh, dang, where did I put that print hello code? You'll be like, oh, it's in the print hello label. And if you want to add something to it, like then you can add that to the print hello command, and you don't have to worry about that messing up the flow with the print goodbye command, right? Yeah, yeah. Hmm. So these labels here are kind of a very prototypical version of what we call a function. A function in programming is kind of a collection of tasks that does one thing. And it's particularly useful if we want to do something like uh, uh, do something over and over and over again. Whoops, I don't want to save. See, I just reflectively hit Control S because I'm so used to just saving my work all the time. Okay, so let's say if you hit the Enter key, it goes to print hello. If you don't hit anything we care about, it prints goodbye. But if the input is spacebar, go to count things. Now this won't work because we don't have count things, so let's make count things. And what count things is going to be, in fact, why don't I indent just to make it. So some programming languages, they actually use indentation instead of braces. So if braces scare you, like a function might look just, with these braces. Um, some languages, they just use the indentation to infer the braces. I think Python does that. Um, anyway, looks a bit nicer, looks a bit more organized. And it becomes a lot easier now to find the labels just by visually scanning the file. But in most languages and in C#, which we're going to be using, indentation does not matter. You can make everything flat. You use spaces or tabs. It doesn't care. But we'll get to that in a little bit. Okay, so count things is going to use a loop. And it's going to say in fake basic, the syntax for loop is loop 10 times the following. And I could say print. Oh, what do I print? Print hi. And just, no, not hi, because I already have hi. What's a cool thing? What's a cool, oh, airplanes are cool. Airplanes. Okay, so now in this code, if you hit spacebar, it's just going to count things. Count things is going to loop 3 times. It's going to print airplanes. Pop quiz. What's that going to look like if you have spacebar? Boop, 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 boop. Time's up. Okay, it's going to say airplanes, airplanes, airplanes without line breaks in between, right? Got to remember, you just told it to write these characters and nothing more. If I wanted line breaks, you'd have to use that secret programmer keyword /n, and then you'd get this. So looping 3 times is great. You can just print a thing. But what if you want to do something more complex? You could start nesting these things together. And here's just a really quick. You could do something like that. I think this is starting to break syntax, but it's fake basic, so we don't care. So now count things is going to loop 3 times running print hello. Now technically, instead of end, we'd need to make this return, I think. And then it will continue on. Okay, so end ends the program. Return just goes back to what it was doing. But that's going to break some things. Can you spot it? Can you spot what's going to break now? So this is live debugging in fake basic. So if you hit spacebar, so you get the input from the keyboard, you didn't hit enter, so it doesn't do this. You did hit spacebar, so it's going to count things. Count things is going to print hello. Print hello is going to print hello. So where are we at right now? It's going to say hello, 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 because there's no line break. There's no /n in the hello. It's going to return. What's return do? It goes back to what it was doing. That means it's going to go back to here. So now it's complete. It'll go to the next line, and then it's going to print goodbye. So that's the bug there, right? So then what we might actually want to do is instead of making this return, we do make that end. Boom. Okay, so that will make it so it just says hello, hello, hello. So you can kind of see why structure might be useful, particularly if you want to repeat tasks. Because you saying loop 3 times, print hello, is way easier than just, like you could instead do that, or you could instead, whoops, oh, come on, hitting the wrong keyboard keys, classic programmer move. Oh, there. I mean, that works too. But the problem with this is, what if someone comes along and says, "Oh, hey, can you capitalize the H?" Then you now have to go in and you have to edit each and every one of these, and that's annoying. So it's way better to have this over here because then you only have to change it in the one spot, right? So you can see how that might be useful, how that might be functional. Those are effectively functions. Okay, so if I pop back into Visual Studio real quick and I show you C Sharp, ooh, scary. Uh, let's ignore these ones for now. The same thing is going to be something like, well, we can use start actually. Start's a good one. Ignore update for now. So all this is saying is this is where Unity is going to start running your code, and this is going to be the equivalent of this right here. So I'm going to just say there's going to be some memorization you're going to have to do at some point. Because then you'll learn things like that. So if you hit spacebar, I'm gonna teach you all these things. So don't worry about that right now. Then you could say print hello. Oh wait, no, we had count things. Count things was our function, and then void count things. Uh, oh, I'm gonna have to do loops. Oh, count things. I like that better. Good old count things. Um, and we want to do that 3 times. Okay, so the difference between hitting spacebar, saying hello 3 times, if we put these side by side, I'm not using hello and goodbye. Uh, uh, uh. So this is very simple and very easy to understand. But this in Unity and in C Sharp is the functional equivalent of the same thing. They both do the same-ish things with various bugs on either side. It's just the way that the code is laid out is a little bit different. And I'm going to show you why each of those components do all those things. Like, why is it different? Why does it say void in front of everything? Like, what are these the doobly doos here? And how do we make a nice little loop like we did on this side before? How do we get all that working? Well, let's get into that. Let's get into it. And what's this mess? Ugh, it's gross, is what it is. It's hard to understand. But each of these things that I just pointed out, like the void and the doobly doos and the blah and the why doobly doo here and how do loop, the reason this looks more complicated is because this layout, the layout and the format on the left hand side, is much more powerful than the layout on the right hand side. And this is why Fake Basic is not a modern programming language that a lot of people use, because you'll very, very quickly run into the limitations of this language and exactly how far you can take it. So let's abandon Fake Basic for a little bit, and I'm gonna break down what all the different parts of this are. Um, I think for the most part, up here at the top of the screen, we got these things that always come in. Well, Visual Studio has this little button here. You just make them go away. You don't want to look at them. You don't care. Whatever. um, this is actually at the top of every code file. This is telling the code what we're going to be pulling from. So if you have this blank, half your things aren't going to work. See, it's complaining because now it doesn't know what this mono behavior is, and it doesn't even know what input is, and it doesn't know what a keyboard is, right? Like it's just confused. But we say, hey, little code. Right now we don't even need these two. You know what, little code? We're gonna use Unity, and Unity is providing to us these things. Um, Without Unity, none of these things would work. Now, different game engines, like Unreal has its own different things. If you're just writing pure C# code, there's different ways to get at hardware and stuff like that. But Unity knows you're trying to make an interactive gaming experience, and that is going to take like they have some shortcuts built in for you that just make your life way easier, right? So let's not pay attention to these. Hide. Go away. Now there's a concept of a class. For the sake of this video, let's this intro step. A class is just a fancy name for a file name. Let's say it's just a file. This is your file, and this colon mono behavior. It says this file hello ants. This is just the type of file it is. It's the flavor of file. And if you mouse over things, it'll kind of start giving you hints. And you see in that super tiny text there, it says it's a base class for which every Unity script derives. Um, you don't need to use mono behavior in Unity, but it gives you a lot of really nice things. Mono behavior is what makes, I'm just going to create an empty game object here in Unity. And I'm going to add my hello ants script to it by clicking add component. There's my hello ant script. This script is able to be added here visually in Unity because it uses mono behavior. If we deleted this, we wouldn't be able to add it in the Unity editor. We'd have to do fancy tricks to make it work. So basically, this whole line, it just says, this is a file in Unity. Woo! And you don't have to care about that. I would say hide it, but it just hides our whole file. So you're just gonna have to visually block that out of your mind. Maybe scroll it off the screen a little bit, pretend it doesn't exist. C# uses these curly braces here to encapsulate things instead of indentation. So even though there is indentation, you can remove it and everything still works fine. It just looks nicer when you indent. So that's just all nice to have. And in C#, anything that starts with 2 slashes is a comment. But comment is spelled right, and none of this gets not compiled. Sometimes you'll also see /star, which lets you do multi-line comments. So all these things in green are things that the code ignores. It doesn't care about. So we're just gonna get rid of all those. And let's go back to this nice start function here. And let's break down what this is and what it's doing. So you see Unity automatically added this very confusing label that doesn't mean anything. So you know what? Let's just get rid of that. And this is a hint from Visual Studio trying to tell you what it is. Ignore that too. Okay. So start is the label. It's the function. This is a thing that gets called. And if we had some other code, another function, that's how we'd call start. So this is how we'd make start run. So functions always have these round things and they're encapsulated parentheses. and they have these braces surrounding them. And to call, and you end lines. You can't just end lines with a blank line. You have to add a semicolon. I don't know why. I think it's so that you can do fancy things like my fancy thing. So complicated. Wow. Whoops. Okay, so you have to add semicolons. So it's not going to like this because it doesn't actually exist. But um, this complex statement is actually just a nice, readable way of doing it all in one line. So that's the same thing. Um, that's harder to parse and harder to read for humans, so they let you break things into multiple lines, which is why you need to add a semicolon to let the computer know this is the end of the line. I'm not doing a fancy thing. I'm just stopping it. Okay, so what is this void? Why it say void? What is void? What is that? And it's a basic type. And of basic types, I can have some code. For example, um, did press spacebar. That's a question mark. Okay, so here this function. It doesn't return anything. It just does something, but it doesn't return any value. So void means nothing. It's not going to do anything. It's just nothing. It got nothing. Bool is it's a boolean. It can mean true or false. There's a bunch of basic data types we can get into, but bool is a true or false statement. So this one, the reason it's got this red squiggly underline, if you mouse over, it'll tell you why. It says not all code paths return a value. It's because we need to tell it return true. And see, now it's not complaining anymore. So now this function is always true. Whether the player pressed the spacebar or not, it's always going to return true. But the usefulness of this is now down here, we can say if did press spacebar, then count things, right? So now this is much more readable than this. But now we have a bug because, of course, when start happens, did press spacebar, it's going to be true all the time. So instead, we're going to take this stuff and we're going to put it here. Look at that. So now this did press spacebar is going to return true or false depending on this. Now this input, this is a Unity thing, and you're going to need to learn a lot about Unity. Unity C# input. If you're ever confused, you just like start typing Unity blah, and it'll tell you. Very first result, always. You just click on it. Documentation is very, very good. The loading times are not very, very good, apparently. I think this is my internet issue. But this tells you, like you could dig deep into all this stuff and figure out like, how it goes. And you could see they always have example code at the bottom, and you can even see how they are using some of the things. So you can always cut and paste this into your code directly. But basically, the input class, so Visual Studio is going to help you out a lot. So you just start typing. Return means this is the value you're going to return. Input, and then you hit dot. Dot is kind of access the parameters of this. What's inside of input? What is inside here? And you can see it's actually got some recommendations. Do you want to get the key? Do you want to get mouse button? Interesting thing, there's get key up. That's when you release a key. Get key down is when you press a key. Get key is if you're holding the key down. So that one might be useful. You just click on it, it puts it in there. Now you need to tell it what you want to listen for, like what key do you want? And you'd see it's telling you it's looking for a key code. It wants a key code. You can't just like type spacebar or whatever, because no one has a key on their keyboard that says spacebar with all those exclamation marks. So you just do key code, which is also a Unity thing, and you can look up dot what's inside key code, and they've got everything. Like every button you could possibly ever want is all in here somewhere, including every letter of the keyboard and everything else. So what I like to do is you just start typing. You're like, I want the number 1, and it's like, do you want just button 1, F1, F10, alpha 1? Whoops. No, no. Alpha 1 is actually the number key 1. Uh, so yeah, and space, key code space is what I want. That makes sense. So did press spacebar is it's going to return true if you're currently holding down the spacebar. That's it. And I'm going to erase this. Yeah, erase that. Nice. Okay, so as you may have guessed, the if statement just does things if it's true. It's very human readable. So the basic format is just, if true, do thing. That's it. So this will obviously always take place. But this true, you can swap for anything at all that returns a bool value. So if you mouse over input get key, see the little hint that pops up, that little blue text right there? It says bool. So it's telling you that this function returns bool. So anything that returns bool, my function, Unity functions, literally just writing true, anything will work for an if statement. And if do a thing, you can actually make this fancier. You could say else do the other thing. So one of the basic building blocks of programming is the if-else block. You can do two different things, switch behavior on different input. So that's that's kind of just the basics here. But let me show you why this particular example doesn't behave the way you might expect in Unity. That should okay. So I'm just going to open up Unity. Hello Ants is in the scene. So code only runs if it's in the scene and it's on a game object, right? So here's my scene view. I've got a game object. In the inspector, I've added hello ants. So now if I hit play, it should say hello, 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 right? But that'll show up in the console, but it doesn't show up. Oh, I forgot to explain debug log. I'm going to do that right now. So Unity has this function called debug. You hit dot. What's inside debug? It's got all these different things. We like using log a lot. This is the way that you just write yourself notes. Don't forget the semicolon. It'll even put a little red squiggly saying you forgot your semicolon. So now on start, it will write hi. Now you go back over to Unity, hit play, and here in the console, there, it says hi. And if you want to know where in my code does it say hi, you could double click on this, and it'll take you and it'll highlight the code that wrote that. Handy. Nice, neat. And why didn't it say hello, hello, hello? It's because did press spacebar is false, right? I was not pressing spacebar, so count things did not get called. So let's see if I'm back in here. I'm still in play mode. I hit spacebar. Get some good Foley work in there. Not working, right? Spacebar doesn't go. It's not doing anything. That's because start runs exactly once. That's why it only showed up once here in the console, right? It didn't keep showing up over and over and over again. It just ran this one time. Just one time. That's it. So if you think about it, like the code ran, you weren't pressing spacebar, nothing goes, this doesn't get called at all, right? So how do we make something check this all the time? Like just all the time. Anytime you press spacebar, then do the thing. Well, there's another built-in Unity function, and it was actually in here, like Unity added this function. I'm just gonna bump this. Whoa, 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 what's going on here? Okay. All right, so this function, update, comes included when you make a new file. And this is a fancy Unity function, and it's called once every frame. So every single time that your program ticks over, it's going to call this function. And we could test that. Just debug log. Uh, here's a fun one. Time.time, it just gives you, if you mouse over it, it'll tell you. It tells you the number of seconds since you started the game. Let's see what that looks like. And look at that. So we could see it now ticking up 4 seconds, 5 seconds, 6, 7, 8. You can see there's over 1,000 messages now. So it's just going to keep counting up no matter what. So this is a basic, what we call a logic loop. So Unity is constantly going to be ticking over in this update loop over and over and over and over again. And instead of just outputting the time, we want to take this stuff from start, the spacebar check, and put this down here, right? So now it's going to say hi once, and then in the update loop, every single update, it's going to check to see if you're pressing the spacebar, and that's going to count things. Count things, or count things. It doesn't actually count anything. Whoa. I forgot to hit save. Control S. There you go back. Hit play. Now it just says hi. If I hit spacebar, every time it hits, or actually it's when I'm holding down spacebar now. And that's what we told it to do. That's just printing hello a whole bunch. So let's just have it print hello once. And I don't want it to happen if you're holding the spacebar. I want it to happen when you tap the spacebar, like the first time you press the spacebar key. If you remember, that's get key down is the keyword for that. All right, and let's see what that looks like. Spacebar. Hello, hello, hello. And now I'm going to hold it down. Just one. Nice. Nice, 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 nice. There we go. So now we have a basic logic. We know how to make spacebar do a thing, and we have a script working in a scene. And hopefully you have some fundamentals now on some of the very most basic tools and kind of code layout. And move this up here. Doesn't matter what order any of these things are in. Unity automatically fires start for you, and it runs it once. Whoops. And Unity automatically calls update for you every single frame. Nice. All right, cool. Nice. Good job. Good job, team. We did it. Close all that down. So that's going to be it for lesson number 1 here on Old Man and the C Sharp. I know it's fast, and I know there's a lot of things to absorb, and I know there's a lot of stuff that's gonna have to percolate through your brain, and you're gonna have to get used to the feel and the look of things like this. And that'll where am I going? That'll come with time, I promise. The thing that I'm trying to teach in this lesson particularly is thinking about atomic units, thinking about the step by step how to make a sandwich, right? Like the step by step, what exactly does the software need to do? What do you want Unity to do for you? And you just break that down into little steps. You can write it all out in the start loop. Like you could write all of your code here, right? And you can blah blah blah, all the different code that you want to do, and you could do it all in start, and it will all run. But don't forget that start only fires once. As soon as the game opens, start fires exactly once. And if you want players to interact with your game, that code won't be able to, like, it's not checking for your keyboard inputs or anything. So all of those inputs, whenever players want to interact with your game, that all has to be in the update loop. And the update loop fires every time, no matter what. So to only act if the player is making input, you have to put an if statement into the update block, which is exactly what we did here, right? So thinking about how to break all of those things down into fundamental steps to make things do what you want, very powerful. And as you go over the years, you'll start building up functions that you use all the time, and you just start cut and pasting across your code. Things like did press spacebar might be an example of something that you reuse a lot. Like you don't want to have to type this every single time. Maybe you want to type that. Or maybe you want to do something a lot more complicated, like, did press space or enter. This is going to be bad code, but uh, like, I'm not going to type it. There's going to be a whole bunch of different complex things you can do that are longer than one line that make a lot more sense to cut and paste around and use in various places because they get more and more and more complex. One of the fundamental rules of programming is if you've ever typed something more than once, it should probably be in a function somewhere, right? Code reuse, we call it. Um, if you only write everything once, then you're constantly building on your previous work. Now, things like doing in-depth interactions and dealing with physics and trying to track, like if you're doing a VR game and the player's head's moving and their hands are moving and they got 17 buttons on the controllers, right? That's overwhelming. That's really hard. It's hard to make something cool and big and fun. And your first instinct is like, okay, how do I make an MMO? Or how do I make Fortnite? And I understand the desire, but just know that those code bases are humongous because they've accounted for, using little if statements everywhere, they've accounted for every single possible combination of events in time throughout the life cycle of the game. And it takes teams of hundreds of people, years and years and years of work to do that, and them using tools that have been built for years and years and years. I'm trying to get you to a shipped title by tomorrow. It's still Saturday morning. We're still on day one. We're doing the base introduction. But for you to successfully ship something tomorrow, you need something simple. Start thinking about what you want to make tomorrow. Maybe it's something very, very easy. Think Flappy Bird, right? One button, one reaction, something happens over time. Easy, right? That's easy. As soon as you start saying the words like multiplayer, whoa, right? Much harder. So Uh, think on what we've learned today, or so far today, because we got more classes to go today. Think on code, layout. Think about that task of making a sandwich. How would you describe to a computer or even a child how to make a sandwich? Think about defining things. Um, and yeah, the next class, we're going to go over some basic logic. We're going to go over like and or, adding to if, and we're going to go into some basic data types. Um, so far, we've looked at Boolean, true and false statements. One of the reasons Booleans are so important, as an aside, is the ones and zeros in binary code that the computer is written in that I was showing way early in the video. All that stuff is it's what the computer knows. Like all computers are written on Boolean true false stuff. So using the true false statements is going to be kind of something you return to over and over and over again throughout your programming career. Basically, everything boils down to true and false. That's it. Just if else. There's not a lot of gradients in programming. It's very black and white. So yeah, that's I think that's it for this class. I'm gonna take a bio break, but we got a lot more learning to do. So you get started, keep socially distanced. If you see me at the cafeteria, feel free to ask me questions, and I will tailor the next lesson based on the responses. All right, we'll get you there. I know it's overwhelming right now. The key is to keep doing it. Keep at it. Just start typing. Start typing what you want the program to do, and we'll figure it out together. All right. Stopping.